5.8 Inverse functions. An inverse means that you're undoing something. So the inverse of addition is subtraction. The inverse of multiplying is dividing. And the inverse of squaring would be to take a square root. Okay, so let's look at, informally, let's look at an inverse. So let's say we have a function that always adds 2 to a number. So let's say that we start with an x and we always add 2 to the number. So if you start at 0, then 0 plus 2 would be 2. And at 1, 1 plus 2 would be 3. And then at 2, 2 plus 2 would be 4, etc., etc. Okay, so the inverse of adding was to subtract. So now let's take these and use them as our new x values. And let's plug those into the inverse, which then would say the inverse of this. And it just froze. Back. And take a value and always subtract 2. So and at 2 minus 2 you would be at 0. At 3 minus 2 you'd be back at 1. And at 4 minus 2 you'd be back at 2. Okay? Let's look at this in ordered pairs and see if we can see some patterns. So 0, 2, 1, 3, and 2, 4 are the ordered pairs for the red function. Blue functions, we use these as our x values, right? So if we plugged in 2, we got 0. When we plugged in 3, we got 1. And when we plugged in 4, we got 2. So compare the x's and the y's, and you should see something here. Okay? Hopefully you're seeing that the x and the y in the red function, this x and that y, they're flip-flopped. This is the y value of the red, and this is the x of the red. And that's what happens with inverses. So inverses is just another, or one thing that you can do for inverses is you just swap x's and y's. Okay, we can also look at this graphically. So we would have a dot at 0, 2. So get a dot here. At 1 we would be at 3. And at 2 we should be at 4. Right? So graphically we get something that looks like this. So this one actually would run this way and this way. I missed this dot a little bit. Sorry. Okay. If you graph the blue function, at 2 you would be at 0. At 3 you would be at 1. And at 4 you should be at 2. If you graph that function, and then you see in this case that the two functions run parallel. Now that's not always the case, but graphically the two functions will look like that. Okay? Let's continue with that just a little bit. In general, inverses undo each other. If you have a table or a list of coordinates, you can just swap your x and y values. So if that's the original function, then the inverse for this function would be swap x's and y's. So 1, 8 becomes 8, 1. 5, 2 becomes 2, 5. And 5, negative 2 becomes, or negative 2, 5, sorry, becomes 5, negative 2. Okay, here, same thing. That's an x and that's a y. So the inverse of this function would look like this. Just keep swapping x's and y's. Alright, then we get to this over here. Inverse functions are symmetrical at the line y equals x. We'll see that here in a second. We'll go back to that. I think we'll and definitely take another look at that when we look at inverses some more next time. And then to find an inverse, you swap x and y and solve for y. So to find inverse here, you swap your x's and your y's. So wherever you see a y, you write an x. Wherever you had an x, you write a y. And now to find the inverse of this function, you solve. So you would write x plus 1 is equal to 2y. Divide by 2. So the inverse of this function, would be the function y equals x plus 1 divided by 2. Okay? You can do that here as well. It's just a little more complicated, but let's just start with excuse me, swapping x's and y's. And then let's go ahead and see what happens when we solve. So x, let's bring the 4 over, so x minus 4 is equal to 2 times y minus 3. Think of these little things as fractions, factors, so you could cross multiply here. So you get x minus 4 times y minus 3 is equal to 2. And I'm going to keep solving for y, so that actually means that I can bring the x minus 4 now over here if I divide by it. So I get 2 divided by x minus 4, and then drop the fraction, or drop the parentheses here, so you can now just look at this as y minus 3 because you're not doing anything else to it. And then to finalize this, you could add 3 on both sides, and so you add 3 over here because it's not a fraction, so it doesn't belong there. So the inverse of that function was y equals 2 divided by x minus 4 plus 3. Definitely a little more complicated, but it is possible. Last one. Again, swap it. You leave the square on there. Solve for y. So let's see, this would be y squared. So if you add 3 on both sides, you get x plus 3. And then to get rid of a square, you take a square root. And then usually when you take a square root, you have to use a plus or minus. Okay. And so we need to stop with this, or at this point a little bit, and consider that. So what happens if you have something like that? Well, that means that if you plug in an x of 1, it could be plus or minus the square root of 1 plus 3 is 4. That would be plus or minus 2. So that means that at 1 we could have a value of 2, but at 1 we also could have a value of a negative 2. And a while back I think we talked about the fact that that is not allowed. That's a repeating x. So right now this is not a function. Okay? So to fix that, people then say, well, let's just use the positive one. So if I cheat a little bit, I could say that y equals x squared minus 3 has as its inverse y equals x plus 3, and that's not completely true. We will talk about this more, so this is for later, as in another lesson, and we will talk about exactly what's going on here and what is not allowed. Okay. So the only thing that I didn't discuss was the inverse functions are symmetric around the line y equals x. Let's look at it here. So the line y equals x would be here, right? 1, 1, 2, 2, 3, 3, definitely 0, 0. So do you guys see that the line is symmetric around this? Okay, so you can mirror the points straight across. If I had a better graph, you could definitely see it. And that is true for every inverse. So if you mirror it if you mirror the original, which is the red one, in y equals x, you will get the inverse. And that has to do with the swapping of the x's and the y's. And then another neat thing over here, if you look at this function, and if you think about all the points over here, x over x, y, so the function is y equals x. So if you're 1, y is 1. If you're 2, y is 2. If you're 3, your y is 3. What happens when you swap 1, 1? So the inverse of this, since we've been using blue for the inverse a lot, what's the inverse of this? Well, it still would be 1, 1, 2, 2, and 3, 3. So apparently y equals x, this is its own, own inverse. And we will probably see that again sometime as well. Thanks.